Hi, I'm Alex. I'm here to tell you how to keep your packages up to date without breaking anything. The slides for this talk are on my personal website. They're not up to date right now, but they'll be up to date sometime tonight. So what is package management? There are a lot of great packages that you can pip install out there. Flask is one of my favorites. Apparently all of you guys have your favorite packages written on your name tags. I arrived before getting that instruction. Dependencies are the packages that your application needs to have installed in order to work properly. And what is there to package management? Packages usually have multiple versions. For example, you can install Flask version 1.0.1 by running pip install flask == 1.0.1. You want to update your dependencies to the latest version to get bug fixes and new features. However, upgrading risks breaking your application. And this is always the dilemma that we're faced with in package management. So the idea is, how do you best continue to upgrade while managing that risk? To start out, you can list your dependencies in a requirements.txt file. This is a fairly standard set of dependencies you might have. And then you run pip install -r requirements.txt to install them. I'm sure for a lot of you, this is pretty standard. It's easy, but you start to run into problems. You deploy right after Django 2.0 is released, and everything breaks because you just specified Django, and you built against 1.9. But then when you deploy your application, it installs Django 2.0, and the APIs have changed, and so your code no longer works. So you end up specifying, the minimum minor version and then the major version that you want to install for all of your packages. And there, perfect, done. In an ideal world, that means you will never get a breaking change because you'll never accidentally upgrade a major version. However, we don't live in an ideal world, and breaking changes come in non-major versions all the time. So you end up going all the way, and you specify every version of every dependency. This is from the same 4 original dependencies, by the way, using pip freeze, which is a helpful utility that comes with pip. This goes on for a ways after my slide. And if you only use this file, I guarantee that you're never going to upgrade anything, because it's just too painful. So what do? You use both. You can have a small requirements.in file that specifies the dependencies that you know are necessary, and the restrictions that you know are necessary. And then you use a requirements.txt file output by pip freeze, and you know that you maybe don't need all of those packages, and you maybe could use different versions than the ones there, but you've tested with exactly those packages and exactly those versions, and you know that's sufficient. So together, this is actually a pretty reasonable strategy, but it leaves a few things to be desired. Pip freeze includes everything you've ever installed in the virtual environment you're running it in. Hopefully you're running this in a virtual environment. Otherwise you're going to have a bad time. Even if you no longer require some of those packages. You installed something, to just test it out. Did you make sure to uninstall it afterwards? Did you make sure to uninstall any of its dependencies that were installed, but not ones that are needed by your other packages? No, you probably didn't. If you download Acme 0.3.0, that doesn't actually fully specify a file. And the file you download today might not be the same one you downloaded yesterday. Could be a man-in-the-middle attack going on. Could be something more innocuous, like a developer decided that release was bad and they uploaded a new file for it. And there's no way to specify using your company's private package index instead of or alongside the Python package index. And if you have separate development requirements or separate testing requirements, you need a separate requirements.in and requirements.txt file for each of those sets, which gets to be pretty painful. So over time, we've developed some tools to help us with these problems. One of the earliest is pip compile. It's part of the pip tools family. So that uses a clean virtual environment every time to avoid installing the old dependencies. It includes hashes of all of your dependencies, so that if a file gets updated or if there's a man-in-the-middle attack, the pip install will fail instead of you downloading something potentially bad or potentially subtly broken, and gives you a really, really loud indication of what's gone wrong. More recently, in 2017, pipenv was released, which works more like npm or yarn if you've used those in Node. It replaces requirements.in files with a new pip file format that has a lot more features. You can specify multiple package indices globally or on a per package basis. You can use two separate groups of dependencies, your default dependencies and your dev dependencies. So if you have things only needed for local development or for testing, those don't have to get installed in your application, and you're still only managing it in one file. And then another strategy that you should consider is bundling your dependencies, where you have a folder in your application's root directory that contains all of the package wheels, basically all of the artifacts that pip uses to install dependencies for you. And then when you actually go to deploy, there's nothing to download. You install those from that local directory. There are some easy tools that help you do that. Wheelhouse is one of the older ones. Dotlock is my own tool, and it has some facilities for that. Obviously, it prevents man-in-the-middle attacks. It's all on your machine. If the man is already on your machine, you've got bigger problems. Prevents dependencies from being deleted from the package index because it's already on your machine. Don't even have to have an internet connection. But it bloats the size of the source bundle that you're deploying. And it's awkward to use with version control because if you upgrade your dependencies, suddenly you're changing a bunch of files that don't necessarily directly need to be reviewed by other members of your team, that kind of thing. So which tool you should use or whether you should bundle depends on your needs. More advanced tools often require more work as a developer and are usually slower. So there's a trade-off there between the higher degree of assurance and the amount of work you have to do. My employer, Coalition, is both a security and an insurance company. So private packages, security, reliable upgrades are all very important to us. So that's why we use pipenv. But pipenv is also a complex tool and a pretty fragile tool, frankly. So that's why I've developed a tool called dotlock, which I'll warn you is still an alpha tool. But it's faster, and I believe it will be more reliable. So this is just a comparison of some of the features that each of these tools and approaches offers. And finally, Coalition is hiring all levels of Python developers. And you can go to that link, or you can come talk to me after these talks to learn more.
What does Coalition do?
We're a cybersecurity insurance startup. So we insure companies against hacking and other cybersecurity events.
Any questions? Any questions? Questions going once?
How does poetry fit in here? Are you familiar with that package?
I am familiar with poetry. Poetry is sort of a competitor to pipenv in the sense that they both do a lot of the same things and they both do a lot of other things that are too numerous to cover in a 10-minute talk. I like poetry a lot. I didn't think I could give it sufficient treatment in this talk, but I would recommend looking into it if you're considering a package management tool.
Similar question. How does Conda fit in all this?
Conda is more of an all-in management system, not just for Python packages, but for a lot of operating system packages. So I think, if you're using Conda, you're using Conda, and there's really nothing else you're going to consider. Otherwise, that's a very root decision your organization needs to make.
Quick question. suppose you over installed one package, then you realize that you need to lower it. Does your package management automatically revert back the?
So generally, you would edit whatever file that specifies your necessary dependencies. So either your requirements.in file or your pip file, or in like npm your package.json file. You would edit that to say install a version less than this version that you know is bad now, and then you would relock your dependencies.